another online chemistry classes. Now today our topic is RS nomenclature. Most of the students have a problem with RS nomenclature. They cannot assign a center whether it is R or S. So we will discuss very simply and some short tricks to determine whether a center is R or S configuration. So first of all, we will have to like to know that what is a chiral carbon. So what is a chiral carbon? When a carbon has 4 different groups in his 4 valencies, that is a chiral carbon, and RS nomenclature is only applicable for chiral carbons. So next, there are 2 formulas that we need to know, that is flying wedge and Fischer. Now if we draw a structure like that, A, B, C and D, then how we will convert this to a Fischer projection? So remember, in Fischer projection we draw it like that. The center is a carbon atom and the 4 groups are in a forehand. We try to keep the longest carbon chain in horizontal position and the most oxidized carbon atom on the top, and these 2 are reserved for the groups or substituents. So first we have to reconfigure it. How? You can see this A and B, the A bond is above the plane and B is below the plane. So we can write like that A is on this side and B is on this side, and if we see from this side, we will see that C is on the top, D is on the bottom. So we will use this configuration and then I will convert it to Fischer projection. And how it is? The horizontal 2 bonds will be above the plane and the vertical 2 bonds will be below the plane. Clear? Now how we will do the RS nomenclature? In simple words, we will assign priority to these groups. Let's take an example like this one. So now this has 4 different bonds around the carbon. So what we are going to do, we will assign priority. See, if we go from carbon, here is one oxygen, here is a carbon, here is another carbon, here is hydrogen. So this side, this is a carbon, this side, this is a carbon, this side, this is oxygen, this is a hydrogen. So oxygen has the highest molecular weight, so this becomes number 1. Now this 2 has carbon, and with this carbon there is an oxygen and a hydrogen, and with this carbon there is 3 hydrogen. So molecular weight of this one is greater than CH3. So this will be priority number 2. And between H and CH3 is the highest greater molecular weight, so it is 3 and it is 4. And we will go from 1 to 2 to 3. So if we go from 1 to 2 to 3, we will have to circle like that, and it is anti-clockwise. So here is the formula: 1 to 2 to 3. If it is anti-clockwise, if it is clockwise, and the number group is in horizontal, number group is in horizontal, then the configuration will be S. And now what we'll do, this is a simple trick now, change any of these 2 and the configuration will become or change. So I am changing this one, I am doing it anti-clockwise and keeping it horizontal, so it will become R. Now I will change both of it. I will do it here. I will change it from to anti-clockwise and I will change it to vertical. So from this to this there is two change. One, this direction has changed and the position is also changed, so the configuration will remain the same. And another, the last one will also be like that. So we have to just remember this table to do the problems. Now we will do another problem which is come in 2016 JEE Mains. The problem said there was a structure given which was like that. So this was the structure and it was asked to what is the absolute configuration of the two chiral carbons. So this one is a chiral center and this one is a chiral center. We will elaborate the structure in bigger way so that we have easy to do so. So now they have given 4 options. The options are 2s 3r, 2s 3s, 2r 3r, 2r 3s. So we have to find out which carbon is number 2 and which carbon is number 3. Sorry, there's a mistake, small. Anyway, COOH has the highest priority obviously, and it is the primary functional group. So this carbon will be number 1, this will be number 2, this will be number 3, and this will be number 4. So we have the main chain numbered. Now we will have to do the RS nomenclature. See, similarly, this carbon is chiral, so this one is oxygen, this one is a carbon, and this one is another carbon. So this one will always be 1, this one now, and this one is always be 4. We all know that. But now COOH and CCl. If we break down COOH, we will get a structure like that. And if we break down this carbon, we will take this whole group as a substituent of this carbon. So the group is this one. So now there is a carbon and there is 2 oxygen. Oxygen's molecular weight is 32 and atomic weight is 16 atomic weight. Now this one has a chlorine in it and its atomic weight is 35.5. So chlorine has a bigger atomic weight, hence this one will be, this side will be number 2, this side will be number 3. So 1, 2 and 3, it is clockwise and it is in horizontal position. So this center will be S, so it will be 2S. So we can cancel out these 2 options. Now 2S, these 2 options is our answer. So coming to this carbon, clearly this group is 1, this side obviously will become the 2, this side will become 3, and this side will become 4. So 1, 2 and 3, it is anti-clockwise direction and H is in horizontal, so it will be R. So as for our options, option A is the correct answer. Okay everyone, I hope you all understand. On the next video we will do some more interesting topics like that. Thank you, have a good day.